Okay, Aritomei. The following figure shows a loaded bracket to support an eccentric load. Two rows of black bolts are arranged to the spacings as shown. Use the following stress value. They have given us tensile stress here 145. They have given us shear stress here 100 MPa. We need to calculate diameter and the actual stress induced in the bolt. So the first thing we need to determine is sum of E L squared about the bottom end. So sum of EL squared, really like a LA again. So each and every LA you need to square it. So this is the formula. And here we are making number of rows, and they told us we have two number of rows again. And then we have L1, L2, L3, L4. So those L1, L1, L2, L3, L4, it's for 4 bolts again. So L1 we substitute 45. L1 L blah blah the space from the middle of the bolt to another center to center of the bolt again. So we have LA, which is 45, is the first one. The second one you are going to say 45 plus 80, you got 125 again. Third one 45 plus 80 plus 8. The fourth one 45 plus 80 plus 80 plus 8 again, and then we got 285. So 1, 2, 3, 4 LA. 1, 2, 3, 4. Yeah, one, two, three, 4 bolts again. So it's 4 bolts, 4 LAs, 5 bolts, 5 LAs. So we got 281, 800 millimeters squared. The second thing we need to calculate is to determine the tensile load due to moment. So this is the formula. Ft moment is equal to P. This P is for the force again. This P is for the force, and then we're given our force in kilonewtons there. We need to multiply by 10 to the power of 3, and then E is the distance from the center until where the load is. So it is 250. We substitute 250 on E. LA, you substitute the last AA, which is 285 again. So we have a force which is 100, we multiply by 10 to the power of 3. We have E, which is 250. We have LA, which is 285. And then we divide by the sum of LA. This is the sum of LA. And then we'll get 25, 25, 25, 28,39. And then this is in newtons again. And then when we divide that in 1,000, so you have 2 comma 2528.
225,283.
It's in 25, 28 comma. So it's 25283 comma 89, and then we divide it 1,000 to convert from newton to kilonewton. We look at 25 comma something again. So it's 25 comma 28 kilonewton. So now we move. So the third thing that we calculate is the load Fs. Load Fs due to the direct shear. Load Fs due to the direct shear. So the formula is force direct is equal to the force divided by the number of bolts. How many number of bolts do we have?
5.
5 again. So why is it 5? Can you have 25 and see you didn't want that? So number of bolts like 5. There is 5 in one row. They told us we have 2 rows. So our number of bolts in total is 10, not 5. 4 is in 5. More cake 1, 2, 3, 4 again. We have 4 bolts. And they told us well, we have 2 rows again. So it's 4 times 2, which is 8. It will be 4 if it was 1 row, but it's 2 rows. So it's this side and the other side. So it's 8. We are able to see 4 here, but it's actually 8. So force here, now what is our force? 100 kilonewtons again. Okay, what do we get? 12,5 kilometers. Remember that we wanted the force, so it has to be in kilometers. We are now going to calculate the equivalent tensile load again. The first force that we calculated, only F what? The first force, F direct. F direct. F A. F moment. Okay, this one is represented by P, I get the letter P. And then F direct is represented by letter Q. So now we're going to calculate the equivalent tensile load. It's going to be PE is equal to half into P plus the square root of P squared plus 4Q squared. Once you've written down again, F moment is represented by P and then F direct is represented by Q. F moment represented by P, F direct Q. This is P. And then the other one is P. So we have PE is equal to 1 over 2. What is our P? 25, comma 283. 283. Okay. Someone can round off. We have 25,3 again. And then plus the square root. What is P? A? P. Even now formula, look at the formula. Formula says P. I should P. P. 25, comma 283. Formula says we square again. So square. And then plus 4. What is our Q? QKF direct. What is our Q? 4 times 12,5. And then the formula says we square the Q again. So we square it. Give formula. Formula is half into P plus square root of P squared plus 4Q squared. Q is F direct. P is F moment. So we substitute there. Repeat like I will equivalent again. Like related to comma. For 2 again. Kilometer. And then now we need to calculate the equivalent shear load. So it is QE equal to 1 over 2 square root of P squared plus 4Q squared. What is our P? 25,283. The formula says it's P squared again, so we square there. And then Q, what is our Q?
12,5.
So it's 4 times 12,5 we square. What do we get? Formula PE, it has P here. Then here, half square root. What do we get? Okay, we've calculated the equivalent shear load. Now, we are going to calculate the combined tensile stress. Combined tensile stress. PT is equal to PE divided by area. PT is equal to area. Area is equal to PE divided by PT. So write down the formulas. Okay, so the formula is PT is equal to area is equal to PE divided by PT. So right now we are looking for the area again, and the formula says area is equal to PE over PT. So what is our PE? PE is this one. Again, we calculated PE, which is 30,
Now P2 cross multiply over PT equals to area equals to PE over.
so then the cross multiply, what about this formula? Eh? Eh?
Yeah.
Cross multiply and check. So our area is PE. PE give like 30,42. 30,42 is in kilonewtons again. So let us multiply by 10 to the power of 3. PT, PT, when they say PT. More, we are calculating tensile stress. So I want combined tensile stress. On our data, they gave us tensile stress. So now we look at 145 again. So PT is the tensile stress. PT is the tensile stress, which is 1, 4, 5. So now we are calculating the combined tensile stress. The combined tensile stress, this is the formula. Is PT is equal to area is equal to PE divided by PT. So we are looking for the area. What is our PE? We calculated it there, and it was in kilonewtons. So we need to multiply by 10 to the power of 3. And then PT is the tensile stress. It was given in the data again, which is 145. Our area is in millimeters squared. It's 209,79 again. So we've calculated the combined stress. Now we need to calculate the combined shear stress. So the formula is Fs is equal to QE all divided by the area, and then we want the area again. So area is equal to QE divided by Fs. What is our QE? 17,78. It was in kilonewtons again. Times 10 to the power of 3. What is our Fs? Fs is shear stress. Shear stress, they gave it to us. That Fs is shear stress.
100.
So it is 100. What is the final answer? In millimeters squared. What's the final answer? 177.5. 177.8. Kamu kalikan 177.8? Yes. 177.8. Okay, so let's go back to the question. Number 1, the diameter of the bolt again. So number 1, we are now answering the question. Diameter of the bolt. Formula to calculate the diameter of the bolt, it is area is equal to pi d squared over 4. Again, pi d squared over 4. So we have tensile stress, we have shear stress again. Here we are going to look for diameter for tensile stress and also for the shear stress again. We need to calculate 2 D's for tensile and for shear. Again, more recently we just calculated the area shear stress, the area tensile stress again. Here we also need to calculate 2 D's. Again, formula it says area. So which area are we going to substitute here? We need to substitute here. We need to do your tensile, shear stress aside again. So this one, what about for tear? What is the area for the tearing stress? 209,79 is equal to pi. What is our D? Here in Yagang it's unknown, and then square divided by 4. What do we do from here? So you have 209 comma, and then times 4 is equal to pi d squared, and then divide by pi, because we want d squared, we want d, not pi d. So divide by pi. This pi cancels this one. So you can d squared is equal to d squared is equal to, let's go punch and the square root once and then you punch once. 209.79 times 4 divided by pi. What do we get? What do we get? So we got 16.34 millimeter again. So now we need to calculate the diameter of the bolts for what? For shear again. For shear, same formula applies. What is the area for shearing? Area for shearing, guys. 177.8 is equal to pi. What is our d? 19 d squared over 4. And then what do we do from here? 177.8 times 4, this comes there, is equal to pi d squared. And then after the step, what do we do? Divide both sides by pi. D squared is equal to the square root of this, which is 177.8 times 4 divided by pi. What is our d? Okay, so we got 15 millimeters, 15.05 millimeters. So the diameter for the tier, it was 16, and then this one is 15.05. So which one is suitable between 15 and 16? Between 15 and 16, which one is suitable? 15. Between 15 and 16, yes, suitable be 15. Huh? Suitable for you. Anything. Oh, which one is suitable? Which one is the most suitable size for bulbs? So the most suitable mark is 16.5 is the one that is highest suitable. So the bolts are naive. This is for, it's not for bolts. We have two rows again. So it's 8 number of bolts and then M20. The reason we have M20 is because this 16.35 can't go backwards again. So 16.35 you are 17. And at the back of the table, page 3 to 9. Aguna M17, there's no M18, there's no M19. The nearest to 17, it's M20 again. So this is the final answer like this. Refer to